What's up, guys? This is Jahangir from Edporium, and today we're going to be discussing how to name those organic molecule structures and how to know if they have the wrong name or not. So this is pretty much going to be just a bunch of practice. Unlike our other videos where I dive into the concept of the why and how, this is just going to be going through each of those practice problems, and hopefully you get an understanding of how to name them and how to understand if they have the wrong name or not. So if you've seen our previous video on naming those nomenclature structures, I think it was the IUPAC naming, where you basically look at like a molecule and it might ask you like what the name of that molecule is. It's something like that. And what we're going to start off doing is write something like 3-ethylpentane. And just from this name, we want to draw out what that organic molecule looks like. So first off, when you look at 3-ethylpentane, the first thing you need to look at is this part over here, the pentane. So that end word, that is going to signal the parent chain, how many carbons there are in a parent chain. And this word pent means 5, so there's going to be 5 carbons. Just like a pentagon has 5 sides. This parent chain is going to have 5 carbons. So that's a great way we can start off with when we're trying to name our structures, is looking at this end word and seeing what that is. Maybe it would be octane, which we know that's 8, or hexane, 6, heptane, 7, and so on. So this is 5 carbons, so let's draw out a carbon chain that has 5 carbons. That's 1, 2, 3, 4, 5. So that's 1, 2, 3, 4, 5. Remember, each of those endpoints and the hills and valleys, those represent our carbons. So we have our pentane here. Now over here it says 3-ethyl. So what this is saying is at the third carbon, there is going to be an ethyl. Now, usually it's going to matter where you start off with. You could start off from left to right or right to left. And there will be specific scenarios where it's actually better to do one. But in this case, since we're drawing out our structure, we can start from left to right, just like we're reading a book. So we'd have our 1 carbon here, 2 carbon here, 3 carbon here, 4 carbon here, 5 carbon. So it's an ethyl group. Ethyl has 2 carbons. So this is going to be something like that. We have 1 carbon here, 1 carbon right there. And that's pretty much how you draw 3-ethylpentane. Remember, pentane means 5 carbons, so the parent chain is going to have 5 carbons. And this 3-ethyl, that number is indicating at what location that ethyl is going to be, at what carbon that ethyl is going to be. So now let's try this one out. So it's 2,3-dimethylhexane. Remember, when we're first looking at each of these molecules, we want to look at that end word. So it says hexane. Now, a hexagon would have 6 sides. So this means we're going to have 6 carbons. So this is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we have 6 carbons in our parent chain. So we pretty much fulfilled this part. Now we have a 2,3-dimethyl. So that di is indicating we have 2 methyl groups, and their locations are at the 2nd carbon and the 3rd carbon. So naturally, I like to count my carbons from left to right when I'm trying to create these structures. So this is my 1st carbon, 2nd, 3rd, 4th, 5th, and 6th. So we have 2 methyl groups, one in the 2 carbon chain, so we have that, the 2nd carbon, and we have 1 in our 3rd carbon. That's pretty much it. And that is 2,3-dimethylhexane. So starting off with this hexane, we know we have 6 carbons. So we created that 6 carbon parent chain. And from that 2,3, those are indicating the locations in which we'd see those methyl groups. And this di indicating we have 2 methyl groups. Now let's say we started adding different elements. Let's say we had 5-bromo 2-methyldecaine. So I want you to pause this video and see if you can draw out this organic molecule. So just like any of our organic molecules, we have to look at this word over here, decaine. A decagon has 10 sides. This is going to have 10 carbons. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Remember, always check the number of carbons you have, because that's one of, if not the most important thing you have to do. And let's start off with this 5 bromo over here. So bromo is indicating we have a bromine, and we have that at our 5th carbon. So we can just count our carbons. This is our first carbon, second, third, fourth, fifth, and we could just do Br right there. They might ask you for lone pairs on this element. So if they do ask you for lone pairs, you can just label them just like this. That's a lone pairs for bromine. If they don't, then just don't put any lone pairs. But it really depends on what kind of question you have, if it asks you for lone pairs or not. So this 2-methyl, we already know 1, 2. We're going to have a straight line because that's our methyl CH3. So that is exactly how you draw that organic molecule. And it's really simple. You just see something like bromo, it's going to say the next one we're going to look at is chloro. So it's going to be really easy to understand which element you're including in that specific carbon region, like for example this 5th carbon that we have. So I want you guys to pause this video and see if you can draw out this organic molecule right here. So to start off, we always need to look at that end word over here, decane. Decagon has 10 sides, 10 carbons. This 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have our 10 carbons over here. And now let's look at this 6 chloro just to get it out of the way. So we have 1, 2, 3, 4, 5, 6 chloro. And let's just say this question wasn't asking for lone pairs, so we don't have to put lone pairs on our chlorine. Now, this is where we get to something a little bit more different, and this is 2,2,4-trimethyl. So that tri is indicating we have 3 methyl groups, but we have 2 of them in the same carbon region. And if you're drawing out, or if you're writing out your IUPAC nomenclature names, or if you're looking at a structure over here, you always need to label the methyl groups you have. Even if you have 2 methyl groups in the same carbon region, you still need to account for that. And that is why in this naming, we have accounted for those 2 methyl groups in that same carbon. So we're going from left to right. So this is our first carbon, second, third, fourth, and so on. And over here, we're going to have 2 methyl groups in our second carbon over here. So it might look something like this. So here are 2 methyl groups right there. And we have another methyl group at our 4th carbon. So maybe something like that. And that's pretty much how you draw that organic molecule. So hopefully going through these questions really helped you understand how to approach these questions, because all you really have to do is look at this end word over here, that decane. If it's a heptane, that's 7. Just correlate it to, your sides that you learned from elementary school, like a heptagon, 7 sides. So that means 7 carbons. Then you want to look in the front and see what naming or what elements you have. So for example, we had chloro, and then you want to go down to see what functional groups you have, like a methyl, an ethyl, a butane, a propyl, anything like that. You want to label that. And one thing that we talked about in our past video on this nomenclature naming is that you want to name it in alphabetic order. You see how chloro is before methyl? Now you don't want to look at this tri, or even if it had like a di, you don't want to look at that, because that doesn't count as our alphabetic order. It counts with when you have a methyl, an ethyl over here, and then you have your chloro. So C comes before M, and you always want to start by naming it in alphabetic order. And if you can, and it would actually be greater if you could write it down in number form. So going from 1 all the way to 10. So you see how in our trimethyl, we start with 2 and go to 4. So you want to be able to do that for all your molecules, but first always put it in alphabetic order. So now let's dive into some wrong nomenclature structures and nomenclature naming, and you can actually identify which one is the right one just by drawing it out. So what I mean by this is this over here. So we have 1,3-dimethylbutane. So 1,3-dimethylbutane. This is a wrong naming. This is the wrong IUPAC nomenclature naming. The reason why is we have to draw it out first. So we have butane. Butane is 4 carbons, so this is 1, 2, 3, 4. We have 2 methyl groups, one in the first carbon over here and one in the third carbon. So here's why this naming is wrong. Because as you can see, we can create a longer parent chain going from this carbon all the way to that one, because we have 1, 2, 3, 4, 5. Instead of butane having those 4 carbons, we now have 5 carbons. And this is actually going to create a better naming structure, because we're not going from 1, 2, 3, 4 and then creating this one over here. We are creating a longer parent chain. So when you're trying to identify which nomenclature naming, which naming structure is the incorrect one, you first want to draw it out and sort of look at where you can find a longer parent chain. And it's kind of like a puzzle. You're just playing around seeing which way can you go to create the longest parent chain. And once you do that, then you just treat that as your parent chain and go on about the whole process. So now, since this is your new molecule, one thing that we talked about in our past video on naming these structures is that you want to make sure any group out here, like this is a methyl, you want to make sure that is on the lowest carbon. And the way you do that is pretty much identifying those carbons or writing those carbons down in the lowest form, if that makes sense. What I mean by this is, you know how we pretty much wrote our carbons as 1, 2, 3, where we're going from left to right? Well, the problem is, since we're saying that this is the correct, we're saying this is pentane, we're basically saying that this methyl is on the 4th carbon. But if we were to go from right to left, that methyl would be on the 2nd carbon. And here's what I mean. So I'm going to erase all of these over here. So just keep a mental image of going from left to right for those, counting those carbons. So just keep a mental image of this being 1, 2, 3, 4. Now if we go from right to left, this is 1, 2, 3, 4, 5. 2 is less than 4. So we're basically associating this methyl group to a lower carbon, and that's exactly what we want. So instead of this being 4-methyl pentane, this is going to turn into 2-methyl pentane. Remember, pentane is from our longest parent chain, which has 5 carbons we've just now identified, and we have 1 methyl group on the lowest carbon. Instead of that being the 4th carbon, it's now the 2nd carbon. If this doesn't make sense right now, don't worry, because we got a lot more practice to go. So the next one we want to look at is 2,2-diethyl butane. So first off, if we want to identify the correct naming structure, we first have to draw it out and find our longest parent chain in that molecule. So butane, like we talked about, that's 4 carbons. So let's draw 1, 2, 3, 4. 1, 2, 3, 4. We have 4 carbons right here, and we have 2 ethyl groups at the 2nd carbon chain. So we have 1, 2. Ethyl is going to look something like this because we have 2 carbons. Ethyl has 2 carbons. So over here we'd have something like this, since we have 2 of those ethyl groups. So now I want you to pause this video and see if you can identify the correct naming structure by finding the longest parent chain. So if you guessed that this was the longest parent chain, you'd be correct. And you can also go from this ethyl over here and descend down, pretty much the same exact thing, but just for visuals, it seems a little bit more better to go from this way, just for me personally. But like I said, you could have gone from this ethyl group down, but this is the correct longest parent chain, because we're going to have 1, 2, 3, 4, 5. Instead of having 4 carbons, we now have 5 carbons. So let's write it over here. Now we have a pentane. And now all we have to do is just look at where we have some other groups, either ethyl group or a methyl group. Over here on the top, we have an ethyl group, and over here on the bottom, we have a methyl group. Now, when we're talking about naming those structures, you really want to emphasize the fact that it comes in alphabetical order. E comes before M, so that's why we want to write 3-ethyl first, ethyl, and we're going to have 3-methyl. So that's 3-ethyl 3-methyl pentane. So that's 3-ethyl 3-methyl pentane. The 3-ethyls over here, 3-methyls over here, and we have 5 carbons, so that makes it a pentane. Now let's try out this one. It's 2-ethyl 3-methyl pentane. Well, we first need to start off with the pentane. Pentane has 5 carbons, so this is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We have 5 carbons. Now let's start with this 2-ethyl over here. So I'm going to go from left to right, counting my carbons. So this is my first. Well, this is 1, 2. So we have an ethyl right there, and then on our third we have a methyl. So now I want you to pause this video and see if you can identify the longest parent chain and try to name it as well. So if you guessed that this was the longest parent chain, you would be correct because we have 1, 2, 3, 4, 5, 6. So now we have 6 carbons, making this a hexane. And in our third carbon, we have a methyl. Fourth, we have a methyl. So literally all we have to do is 3, 4 dimethyl hexane. And once you get more practice with this, you can actually solve it much faster. But just as a sort of review of what I just went through, we have our longest parent chain going from this carbon over here all the way to that one. So that created 6 carbons, which creates a hexane as our longest parent chain. And then we just descend down and see which ones have a methyl group, an ethyl group, a propyl group, anything like that. And when we descend down, we have 2 methyl groups, one in the third carbon, fourth carbon. So to constitute those 2 methyl groups, we have this di word over here, and then 3, 4. So when you're writing out your nomenclature, you're writing out your naming, you really want to make sure that when you write those numbers, it comes from the lowest number to the highest number, sort of like counting to 10. All right, so now let's look at this molecule right here, 2-propylpentane, and I want you to pause this video and see if you can find the correct naming and as well as drawing out this structure. So we have a pentane. Pentane is going to have 5 carbons, so we have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So we have 5 carbons. And at our second carbon, we have a propyl. Propyl is going to be 3 carbons. So that's 1, 2, 3 carbons right there. And our longest parent chain is going to descend from this propyl all the way down. And this is going to create 1, 2, 3, 4, 5, 6, 7 carbons. We have 7 carbons. And at our third carbon over here, we have a methyl. So this is going to be, the fourth carbon, we have our methyl because this is 1, 2, 3, 4. So this is going to be 4-methyl heptane. So now let's get into our last structure. And this is going to be a little bit more difficult than our past ones. So we're going to have our 2-ethyl, 3-methyl, 5-propyl hexane. Just like all the other problems, I want you to pause this video and see if you can identify the correct naming structure. So first off, we need to start with that hexane right there. Hexane has 6 carbons. So we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. We have 6 carbons. Now we add this ethyl at our second carbon. So that's ethyl right there. We have methyl right there, and at our 5th carbon, we have a propyl. So this is 1, 2, 3, 4, 5. We have our propyl. Now from here, we're going to identify our longest parent chain from this carbon over here, descending down that zigzag all the way down to this propyl, the end of that propyl. And this is going to turn into 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is going to be 9 carbons, and at our third carbon we have a methyl, fourth we have a methyl, sixth we have a methyl. So this is going to turn into 3, 4, 6 trimethyl because we have 3 methyl groups, and nonane. So 3, 4, 6 trimethyl nonane, and that is our correct naming for this organic molecule. So hopefully that helped you guys understand the naming structures and how to identify the correct one versus the incorrect one. And as always, a Pomodoro day will make you a doctor someday. I'll see you guys in the next one.